Hello, and today's purpose of the day is I can use the Pythagorean theorem and distance formula. Let's review a little about the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. And then if we look at that a little bit more closely, we can talk about the hypotenuse and the legs of a triangle. And so if we look at the hypotenuse, we'll remind ourselves that this is also called the diagonal. It's also known as the variable c in the Pythagorean theorem. It connects legs of the triangle. And it's known as the longest side. And we could even say it's across from the 90-degree angle. Oops, fix that. Across from the 90-degree angle. So if I'm given my right triangle here, A and B are the legs, and C is the diagonal or the hypotenuse, and that again is across from the 90-degree angle. So I can draw that arrow right there. And if we talk about the legs of a triangle, they are the shorter sides of the triangle. There are two legs in a right triangle, and the two legs come together to form a right angle. So once again, I have a picture right here that is set up with the Pythagorean theorem. So again, the two shorter sides are the legs called A and B. Diagonal is known as C. And let's look over here at an example. So if I have to solve for hypotenuse, again, this should be review. I want to say 6 squared plus 8 squared equals c squared. And then 6 squared is 36 plus 64 equals c squared. 100 equals c squared. How do I undo something that's being squared? Take the square root, and so c here would equal 10 units. Again, this should be review. And now if we have to solve for a leg, this is a little bit different of a setup. So here I would say a squared plus 12 squared equals 16 squared. Again, I'm solving for a leg. So what I have is a squared plus 144 equals 256. Subtract 144 from both sides, and a squared equals 112. And again, take the square root and get a equals 10.58 units. Now let's look over here. And now we need to determine if the measures can form a right triangle. So what we're going to do to figure out if three numbers can perhaps fit into the Pythagorean theorem and form a right triangle is we're going to use those numbers and put them into the Pythagorean theorem. So I'm going to type in my calculator, or think about, here is 30 squared plus 40 squared equal to 50 squared. So that would be 900 plus 1600. Does that equal 2500? It does. So yes, these values would be able to form a right triangle. Let's try out another example. 6, 12, and 18. So I'll say 6 squared plus 12 squared. Does that equal 18 squared? And again, I know how to put these in the right order, A, B, and C, because C will always be your largest number or your longest side. So we know that that will always be C. So that's why 18 was C here. And 36 plus 144, does that equal what 18 squared is? No, it doesn't. And again, that doesn't equal because 18 squared is 324, but really 36 plus 144 is 180. So those numbers would not form a right triangle. Now we are going to recap the distance formula. The distance formula is d equals the square root of x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. And I have a little diagram over here to take a look at. So what we're trying to do is, if we know two coordinates, we want to find the distance between those two coordinates. And we're also going to look at a different example, which we'll get to in problem number 2. But let's start with the first one. So find the distance between the 2 points 4, 2 and negative 3, 1. So I'm going to zoom in here, and right away I'm going to label what x1 and y1, x2 and y2 are. So I know exactly where to plug those into my formula. And again, I called 4, 2, x1 and y1 because that's the first x term I'll look at, or x coordinate, and that's the first y coordinate I'll look at. And then my second pair was the second x coordinate and the second y coordinate. So if I go ahead and use this formula, I'm going to write d for distance equals the square root of, now I need x2, which is negative 3, minus 4, the quantity squared, plus y2, negative 1, minus 2, the quantity squared. So distance equals the square root. Negative 3 minus 4 is negative 7 squared, plus negative 1 minus 2 is negative 3, the quantity squared. So now negative 7 squared is 49, negative 3 squared is 9, so square root of 49 plus 9 is square root of 58, which we could type in our calculator, round to the nearest hundredth, and get 7.62. And I could say units, because distance is just in units, so 7.62 units. Really not too difficult, just using the formula, making sure you are plugging in those coordinates correctly. Now let's look at a different example. Now let's go ahead and take a look at the second example here, where it says find the possible values for A if the distance between points at 4, 7 and A3 are 5 units apart. So a little bit different than the last example where we just had to plug in the coordinates that we were given and find the distance between the two. Now we're given one of the points and half of the other, where we have to solve and figure out what could be 5 units away from the given point 4, 7. So I will call 4, 7 x1, y1. I'll call A x2 and 3 y2. Now I'm going to use the distance formula, but now I'll have different values to plug in, meaning, a variable A instead of a number. So I will say the square root of x2 minus x1 would be A minus 4, the quantity squared, plus squared plus y2 minus y1, the quantity squared, and that is equal to the distance, which here they've given us is 5 units. So let's simplify this here. Now I'm going to look at A minus 4, the quantity squared, which really means A minus 4 times A minus 4, and we already know how to do that with FOIL or the box method. So A minus 4 times A minus 4, I'll simplify right here, gives me A squared minus 8A plus 16, and then 3 minus 7 is negative 4. The quantity squared is positive 16, so I'll add 16 again, equals 5. Now I want to get rid of that square root on the left-hand side here. So how do I undo something that's being taken the square root of? Well, I square it, so I must square both sides. And when I square something that's being taken the square root of, those two operations cancel out, and I'm left with A squared minus 8A. Combine my 16s and get plus 32 equals 5 squared is 25. Now, this is a quadratic equation that we just learned in chapter 8 how to solve. So what I want to do here is I want to get everything on one side. I'm going to scroll up here like this, and now I'm going to subtract 25, bring that 25 to the other side, let's erase that, minus 25, and I get A squared minus 8A. 32 minus 25 is 7, equals 0. Now I'm going to use the diamond method because 1 is in front of A squared. So factors of 7 that when added together give me negative 8 are, you guessed it, negative 7 and negative 1. So I get A minus 7 times A minus 1 equals 0. So my two solutions are 7 or 1. And I could use 7 or 1 because, again, this was an ordered pair. So to figure out oops, there we go. So to figure out that missing distance here of the coordinates, 7 or 1 would be able to fill that missing spot for that half of that coordinate for A. Okay, let's look at one application problem using the distance formula. So this application problem reads, Addison hit a golf ball from a tee to the point at -312, 12 feet past the hole and 3 feet to the left. The hole is located at the point at 0, 0. Her first putt traveled to the point at 1, 2, 2 feet above the hole and 1 foot to the right. So question A, how far did the ball travel on her first putt? Well, if we look at this, she's putting from the tee at -312 and then to the point 1, 2. So we need to find the distance between those 2 points. So if -3 would be x1, 12 would be y1, x2, y2. I'm going to use that distance formula that we already learned about. So I will say distance equals the square root of x2, so 1 minus -3. 2 negatives together give me a plus, the quantity squared, plus 2 minus 12, the quantity squared. And then now I'm going to simplify. So distance equals 1 plus 3 is 4, the quantity squared, plus 2 minus 12 is -10 squared. And now I'm going to simplify again. Distance equals 4 squared is 16, plus -10 squared is 100. So distance equals the square root of 116, which I'm going to simplify 2 different ways right now. That is roughly, rounded to the nearest hundredth, 10.77 feet. Or let's break this radical down. So I'm going to break down 116. I'm going to think of a perfect square that goes into 116, which would be 4 and 29. And the square root of 4 is 2. 29 cannot be broken down. So I could say 2 square roots of 29 feet would also be an acceptable answer. So both of these answers right here would be correct. All right, so part B now, that was for part A. Part B says, how far was her first putt from the cup? Well, her first putt ended up at, I'm going to scroll down here. Her first putt ended up, this is part B, at 1, 2. And the actual hole is at 0, 0. So now we have to find the distance of how much she was away from that hole. So x1, y1, x2, y2. So I'll say distance equals the square root of 0 minus 1 quantity squared plus 0 minus 2. And again, I'm just using the formula. So distance equals -1 squared plus -2 squared. And then I get distance equals 1, square root of 1 plus 4. And 1 plus 4 is just 5. So here, my answer could be square root 5. Or if I decide to figure out what that simplifies to, that would be 2.24 feet. So I could choose either one of those for my answers. And I can't break down 5 because there's no perfect squares that goes into 5. So I could say square root of 5 or 2.24 feet could be an acceptable answer.
Thanks for listening and have a great day. Bye-bye.